Welcome to PowerUp, a podcast show hosted by Maurizio Di Paolo Emilio that brings life to some of the stories on power electronics technologies and products featured on powerelectronicsnews.com and through other AspenCore media publications. In this show, you'll hear both engineers and executives discuss news, challenges, and opportunities for power electronics in markets such as automotive, industrial, and consumer. Here is your host, Editor-in-Chief of Power Electronics News and Embedded.com, Maurizio Di Paolo Emilio.
Hello everyone and welcome to this new episode of PowerUp. Today, the title of this episode is Efficiency and Performance in Modern Power Design. So we will understand we are focusing on a key challenge in power design: how to deliver higher efficiency, reduced EMI and advanced thermal management, all while minimizing size and complexity. So these demands are especially critical in applications like data centers, industrial systems, communications, where power density and performance are important. Our speaker is Anton Winkler, a systems engineer and power modules technologist at Texas Instruments, TI, where he drives the development of new processes and technologies for power modules. During this podcast, we will discuss in particular TI MagPack technology that integrates magnetic packaging to deliver unmatched power density, reduced EMI, and improved thermal performance. So let's talk with Anton. Hi Anton, thanks a lot for being here. How is it going?
It's going really well. Thanks, Maurizio. Great meeting you again.
Thank you. My pleasure. So where are you located, Anton?
I'm located here in Freising, Germany. That's next to the Munich airport. And this is in the Texas Instruments European headquarters.
Great. So today, as I mentioned at the introduction, we'll talk about power design, MagPack technology. But before that, tell us more about you. Please introduce yourself.
Yeah, so my name is Anton Winkler. I'm a product definer and a power module technologist here in Texas Instruments. I'm working for TI since 22 years, so it's been a while. And I had several roles in that journey. So I started off as a test engineer doing production test programs. Later on, moved over to applications and then systems engineering, which is product definition. And now I'm focusing more on the power module side, and then in particular also in process development and process optimization. So it's a combined role what I have. So I'm speaking to customers, getting their inputs, but I also shape then the technologies to fulfill those requirements.
Great. Thank you, Anton. So let's talk. Let me share my first question for you. So in power design, size matters, as you know. So the need for smaller, more efficient power modules is critical in applications such as data centers, communications, and so on. So from your perspective, what are the biggest trends shaping the power module landscape today? What about thermal management, EMI reduction, and system-level power losses in these demanding environments?
Yeah, you're absolutely right. I mean, not just in data centers, but also in many more areas, efficiency is really critical, and also size. Because if you have a smaller power solution, you just have more space for other critical components like the connection of the memory to the processors and so on. So in terms of trends, I see there are a couple. I would say the first one is in packaging. So there's an advanced packaging trend. You can't achieve a reduction in size if you don't have the right packages. And our MagPack packaging technology achieved that. So we can actually shrink our module size by about 50% compared to our previous generation, while still keeping thermal performance in mind. So this really helps us in order to shrink the size and also get the highest power density, so basically increase the efficiency. That goes hand in hand with thermal management. So if you shrink the solution size, your thermal resistance ultimately goes up. And there are you can either increase the efficiency or you increase your thermal performance, so the connectivity or how efficient you can transfer heat from your heat source to your heat sink. And MagPack also helps us here on that sense. So we've designed it in a way that this improves the thermal resistance by a factor of about 2.5 compared to the traditional approach we had before. Mm-hmm. And so thermals is a critical component here. Yeah. Also EMI, that also plays hand in hand with that same trend. When you look at the power losses you have across the load range, the switching losses are a big contributor in those losses. So you can decide either to switch slower to improve your EMI performance, or you switch faster and then get a better efficiency. So there's a trade-off, and you obviously need to fulfill certain regulatory requirements, but also, electromagnetic interference. You don't want to interfere with any critical signals. So it's a trade-off. And the way we've designed our MagPack packaging technology helps us optimize in that range as well. So for example, if we compare this technology to our previous generation, we were able to reduce the EMI radiation by about 8 dB. And then we can decide if we want to invest this 8 dB in faster switching and then push the efficiency up, or if we want to have lower radiations in order to push boundaries in terms of EMI radiations. When we talk about system efficiency, that's the overall goal. That directly translates into energy costs in data centers, and this is one of the biggest factors for cost there. So with MagPack, we can shrink the size and increase the efficiency. For example, in the devices we've released, we were able to shrink the size by about 50%, but at the same time push the efficiency up by another 2%. So this is really beneficial for these critical applications. Yeah.
Good. So Texas Instruments, TI, announced last year new power modules, 6, I guess, new power modules featuring MagPack technology, promising significant advancement in size reduction, in efficiency. So may you tell me more about the technology behind the MagPack technology and how it stands out in the market? So this technology introduces integrated magnetic packaging with proprietary material. So what was the inspiration behind this innovation, and how does it differ from traditional approaches to power module design?
Yeah. So when we started with the MagPack technology, we had a clear vision in mind. So, and then we just talked about the trends we see for power modules, and this was exactly the inspiration for our technology. So we started with a blank sheet of paper. We said we don't want to base it on any existing technology. Our goal was really to optimize for the customer's needs. And so it's a completely new technology, which is not out there in the industry yet. And it's the tightest integration between silicon and passives. In classical modules, you see always that they are using off-the-shelf components, like off-the-shelf inductors. But there is, with this approach, there is unused volume. So volume which is not part of the power module, it's just air, because the inductor can never go from the one edge to the other edge. With MagPack, we have achieved that. So we're really pushing the boundaries here and maximizing the usable space for our customers.
Okay.
And that helps us to shrink the size and push efficiency. And as a side effect, we also get magnetic shielding of all the critical traces and reduce EMI.
Good. So one interesting intriguing part of this development is the optimization of the inductor using a neural network-based approach. So can you explain the theoretical basis behind using these neural networks for this type of optimization, and how it will differ from conventional optimization methods in power?
Yeah, sure. I mean, in normal optimization methods, you're kind of limited in what kind of factors you can consider before things are getting too complex.
Mm-hmm.
And as with MagPack, we are actually building the inductor. So it's not an off-the-shelf inductor we purchase, which has a given set of parameters. We're actually building and designing the inductor. And so there is an optimization process in terms of size, and also there are a lot of spacings we need to consider inside the package. So we consider way more parameters than on a classical approach. And these neural networks help us to optimize the performance across the entire load range. So we're not just looking at a few operating points, but we really push the efficiency across the entire load range. And I mean, this is an internal software which helps us design the product, but it's also a sign for customers that there is a lot of commitment behind or pushing the boundaries and really squeezing out the last efficiency point or shrinking the size.
So during the processing, so what specific challenges did you encounter during so the development process, especially when it came to combining the inductor with the integrated circuit in such as compact space? Just talking size.
Yes, as I said before, we started with a blank sheet of paper, so everything was new, and the biggest challenge was getting the reliability up. So we always had reliability as the highest priority. We want to have a good product which doesn't have any compromises. So overcoming this challenge was critical. There was a lot of plan Bs. Also, in terms of spacing inside the module, we really want to squeeze the size down to a minimum. And that came with its own set of challenges. So it took us quite some time, so nearly a decade since we started the first ideas. And I mean, we ended up with a fantastic product with very high reliability, and that was the goal. And we only wanted to release it once we're at that stage.
So what's next from MagPack? So from this point of view, what obstacles do you foresee in meeting automotive standards?
Yeah, automotive is has a lot of challenges. I mean, we're talking about extreme temperatures, vibrations, or very high demand for reliability. And when we developed MagPack technology, we always had that in mind. So our goal was always, let's build it that we can tackle this kind of challenging environments. And so things are looking quite promising from the qual results, and I'm confident that we can get there. Yeah, so there was always this thought, let's go automotive with this technology. And so with the next steps, we will push the output currents going higher, and then further increase the power density, and that's in line with the demands we see in this market.
Great. So looking forward to it. And so my last question, Anton, just talking in general. So looking forward from TI perspective, what can designers expect from TI in the next few years? Talking about in different point of view for power design.
Yeah. So designers definitely can expect us to push these boundaries even further. I mean, this is just a starting point. We're gonna you utilize MagPack more across the board. So there will be more products coming out using this technology. So our focus is on fulfilling the customer requirements. We've talked about the data center users before, where they need smaller size, more efficient, and so more integrated solutions. And then customers will see this coming. So there's a commitment from our side that we push those boundaries.
All right. Thanks, Anton. Thanks a lot for your time, and stay in touch with other power design topics. Thank you, Anton.
You're welcome. It was great talking to you.
That brings us to the end of this episode. Stay tuned for more news and technical aspects about power electronics. If you are listening to this on the podcast page at eetimes.com or powerelectronicsnews.com, links to articles on topics we have discussed are shown on this page. Power Up is brought to you by Aspen Core Media. The host is Maurizio Di Paolo Emilio, and the producer is James Eade.